Good afternoon, good evening, everyone. So we are team group 9 who are using Cosmos DB. Our main topic will be event scheduling system, and my teammate will be Tomoki Kyodani and myself, Genjin Su. And yeah, we'll go on to our objectives. So to begin with, right now our target will be basically on our Seattle campus. So right now it's a little bit messy on the scheduling system. It has two entry system and multiple calendars. So we are looking for a unified entry system, a single calendar. Additionally, we want to provide a more efficient analysis tool for the new managements. And finally, we hope to support the Seattle campus, and I'll pass on to Tomoki for the data structure.
This is our architecture diagram. We have, for the historical and existing data, we got those Excel files from the Seattle campus team, and we perform one-time initial load using Python script into our relational database, PostgreSQL. And for the ongoing and incremental load, we built a very simple Django web app, so users can input and schedule new events or classes. And those data will also be stored in our relational database. And weekly, we move the weekly schedules into our Cosmos DB for NoSQL, so document database. And we built one data pipeline for that. And we also built another data pipeline to extract current relationships between courses, events, schedules, and rooms, and store them into Cosmos DB for Gremlin. And for visualization, we use Power BI and GWB. This is our ERD for relational database. The main entities are room, course, event, room assignment, and schedule. And on top of those entities, we decided to keep track of the changes in our schedule table. So we have three audit tables for that purpose. This is the ERD for our graph database. We have schedule, event, room, course nodes, and scheduled at and assigned to edges. And this is our ERD for document database. Within the schedule document, we embedded the course and room and event documents. Luis will talk about our initial data load. I think you're muted.
So next slide, please. So begin with, so we have obtained data from our current Seattle campus operation team. So the data is kind of messed up. It's in multiple formats and multiple styles. So we created Excel and CSV file from all those resources. From there, we connected to our online servers on Azure database for Postgres. And then through Python scripts, it's on the site so you can see how we're connecting it. Reading all those files in, we use the iterrow function to simply read each row and then import it through our customized query language. And passing on to Tomoki, we'll have our refreshing data.
For ongoing and incremental load, as I said, we developed the Django web app, and we create a simple form website using Django Web Framework to allow users to schedule a new course or event. And in order to update existing schedule or course or event, we temporarily utilize the Django's admin page that comes with the Django framework. And the data stored in this data captured through this form will be stored in our relational database. And quickly just showing how our web UI looks like. It's pretty simple. Definitely there's a room for improvement, but this is how users can input schedule, like select the room, course, and input other details. And then they can look for the existing schedule, they can click on it and then just shows the details. And to edit them, they can go into this admin page that comes with Django and then like select schedule. And yeah, they get edited from there. And I'll talk about the data pipeline we built for our graph database. So Data Factory does not officially support connection to or from Cosmos DB for Gremlin. So we wrote a Python script instead to fetch data about course, event, room, schedule, and their relationships between each other from our relational database, and we store them as nodes and edges in our graph database. To run this Python script, we set up a Azure batch service pool and node, And Data Factory basically utilize this environment to run the script. And we run this script weekly using the resource on batch service and Azure Data Factory and perform the full data refresh. Now, Luis will talk about our data pipeline for DocumentDB.
So next, so right now we have one initial load and one for future import. It's very simple pipeline. So inside these pipelines, there's three main streams. One will be for course, one will be for one-time events, and finally for recurring events. As three of them are very, very different within our database. They have recurring status, recurring start dates, and etc. So we created separate pipelines on there. And then as Tomoki mentioned, these pipelines are all scheduled weekly to update the schedule. Yes, it will be scheduled every Sunday at 5 p.m. Pacific time, which is where Seattle campus is. And next slide, please. Go on to the visualization.
Yes,
Yeah,
for the visualization of graph database, we use the G.B, and just quickly show how it looks like. If you want to see all the relationship, you can just run G.B. and it shows all the relationships. And it's very nice that it's how interactive it is. So you can click on it and then click on the node and you see the more detailed information. Or if you want to look at the schedules all happening on Wednesdays. Oops, I don't have G.B. Wednesdays, you can just like run this query and see the events that's happening on Wednesdays. I think you're muted, Luis, again.
So we will also be demonstrating this Power BI. So would you mind? Yeah, thank you. So mainly as our objective is showing, we want to create a single schedule calendar. So through Power BI, we are able to achieve this. So right now you're seeing like April, like this month. And also, can we go back to maybe March? So in here, we can actually see different events and different things on there. We can also isolate it from, like, for example, if we are picking room 102, like these are the events happening there, and we can actually check like maybe different rooms in the future. But right now, these are all different events and courses. So yeah, we'll see, to even change to today, we'll also see like what's happening around today, which is the yellow box there. And yeah, you can also see the blue are classes and green are events. So right now it's still like demonstrating data, but in the future, when the campus or the management starts inputting more data, it'll be more clear. Inside each block, there's also the contact and everything. So yeah, this is our visualizations. And finally, to conclude our presentation, we have some future improvements that looking back on everything we did. So first of all, since we are focusing mainly on database structure and data pipeline, so it's definitely there's potential growth in our UI UX design, which right now is a simple page without any templates or static files or even CSS there. Then on the moving on for our SQL database, we can also add more server-side modules, additional procedures, even more on the constraints for data regulations. Currently, there's definitely some data integrity issues in our database, but adding all those in the future, it will definitely kind of fix it. And finally, moving on to the data flow, which will be additional functions in data pipelines. So right now, since we are loading it weekly and the data will never be duplicated, it will be fine. But in the future, if the management needs manual run on the pipelines, it will definitely have these potential duplication. So using the data flow in, for example, exist merge to check if it's existing in the database, it will definitely improve the data, the whole data structure and database. So this concludes our presentations, and thank you everyone. So we welcome any questions.
Hi, I had one question.
Yes. Please.
On the data factory part of it, you said you used the data factory to execute a Python script?
Yes.
Yes.
For the data pipeline for a graph database.
Got it. What's the component called? This is
It's under batch service and it's called custom. Yeah.
Oh, okay. And you can use it to underlie just Python code or anything else as well?
I believe it gives you the computation part resource. So it's like kind of building your virtual machine. So you can, I believe you can run whatever you want as long as you have the like files that you want to run.
Oh, okay. Thank you.
Yes.
I have a question. Can you go to the
Yes.
architecture diagram once?
Yes.
Yeah, you mentioned that you are creating two different data pipelines.
Mhm.
Yeah, can you explain once again what those are for and why you did not choose to do it in a single pipeline?
So that's
It's,
I will
go ahead.
so the main thing, so we kind of skipped that part when doing the demonstration. For the graphical database, we are actually using to visualize all the historical data. It's using for analysis, and for the document DB, we are using for scheduling database. We don't want to overload each of the pipelines, so we separate them into two. So for the graphical, it will be used for future analysis. For example, in the nodes, we can analyze like which rooms are used more, when are the rooms assigned, and how is it expected, even for events and future courses assignments. And for scheduling, it's really just to kind of demonstrate how the scheduling system can be for the current management. Did that clear up
Okay.
the
Got it.
question? Thank you.
Yeah, clear. Thank you.
So if there's no questions, I think thanks everyone. So yeah, enjoy the rest, and we look forward to following presentations.
Great work and the presentation from Team 9. And this is also a very interesting project. So Luis and Tomoki, will this project be in production soon? Will this solution be in production soon?
So we are planning to propose this next week to the campus, and we hope that in the future they can actually kind of hire students in maybe interns to kind of actually develop the whole from the UI. And since we have the database structure design, it's actually simply just the UI will be fine, and finding a server to deploy.
Right. I think this is going to be much better than what they have now.
Thank you.
Excellent.
Thank you.